Hey, what's up, Science 9? It is Mr. Yago. Sorry, this is going to be a very quick vid. No intro music, no noises. Sorry. What I'm going to do today is go through covalent bonding, and you are watching this either because you are gone, need a little bit of extra help, or you wanted to kind of move ahead a little bit. So I am going to go through these slides. You have access to these on Canvas. You as well have that student note sheet, which you could have out while you're going through this. Today's goals. We're going to be going through the role and location of electrons in a covalent bond. We are going to continue to draw Lewis structures that show covalent bonds, and we're going to learn how to name them. Basically the same thing we did with ionics, except we are now going to be going through that with covalence. So first thing that I'm going to talk about is what a covalent bond is. It is formed when atoms share electrons, which contrasts from ionic bonds where we donated from the metal to the non-metal received those. So the shared electrons actually are going to move between the clouds, which are pretty much like the shells that we discussed. So for instance, hydrogen is going to have one electron floating around here. Hydrogen actually can form a bond with itself. Well, not really itself, another hydrogen ion, and then it'd be H2. And then we can make this bond, and then those two electrons will float around. So we'll get into a little more detail with that. This is always between two nonmetals. They tend to have low melting and boiling points, as where our ionic bonds tend to have high melting and boiling points. They don't ionize in water, but they can dissolve. For example, sugar is a covalent bond. All nonmetals can dissolve, but it does not ionize. Ionize is where like salt break apart, charge up the water, become an electrolyte. Lewis dot structures will use lines instead of arrows, which we'll be discussing. Remember, we drew arrows to show our Lewis bonds, and they are much weaker than ionic bonds. Ionic bonds are very, very strong. So Lewis dot structures, in this case, are going to be different between the ionics and the covalents. Covalents are going to use those lines like we said. Looking here, this in the bottom right-hand corner is between a metal and a non-metal. This is ionic. But right here, this is a bond that is covalent. So this line that you see is actually representing two electrons. For instance, carbon should have 4 dots around it. It's in group 14, has 4 valence. Chlorine, 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 and fluorine all have 7 because they're in group 17. They have 1. So if we circle around here, you're going to see that if that line represents 2 electrons, one being shared between each of them, this would technically be 2, 4, 6, 8 total electrons. We're going to get into that in a little bit more on the next slide here. So Lewis structures, as you know, show valence electrons. Valence are the number of electrons in the outermost shell. We look at the group numbers vertically to determine that. But to figure out how many bonds an atom would make, simply look at its valence electrons. If they don't have 8, they want a bond. Our noble gases all have 8, don't want a bond. The example I give is chlorine. Chlorine has 7. It is looking to form one more bond. Often it does form a bond with elements that have 1 to give, and not in this case, 1 to share. A little vocab word that you might want to put out there is something called a lone pair. A lone pair is a non-bonding pair of electrons in the valence shell. So technically, if you look at this image, this chlorine has 1, 2, 3 lone pairs on that atom, and 1, 2, 3 lone pairs on that atom, and then this is shared. Remember, that bar means how many electrons? 2. So 2, 4, 6, 8, 2, 4, 6, 8. Everything is shared between them. Things can get a little crazy. This is a triple bond. This is nitrogen. Again, each of these lines represents 2 electrons. So this would be 2, 4, 6, 8. So these are shared for all this specific element, this atom. And then we have 2, 4, 6, 8 over here. So these lines are actually shared between both elements. Now, in terms of naming, covalent compounds have a different naming system than ionics. Second element still ends in "ide." However, covalents don't use swap and drop. So they have to tell how many atoms of each element are in a compound, and you do not want to reduce them. Here are the prefixes or code words we use. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. And we're going to use all of these prefixes to determine the specific amounts of atoms in a covalent bond. Let's see what that looks like. So covalent bonds use a prefix. If we were to look at water, H2O, di means 2, hydrogen, 1 means mono. So water is dihydrogen monoxide. If the first element only has 1 atom, you don't technically need to put mono. So for example, SCl, we have 1 of each. Don't write monosulfur, but you can write sulfur monochloride. So take a second. All you got to do is just look. You look and see what you have, and then you are able to draw. And obviously, we're going to make you do the opposite. We would cover this up and say, hey, what is dihydrogen monoxide? You would say di2, so H2, mono 1, oxide, H2O. So that's how we go about naming. So you're going to have access to these as we're going through this. It should be on your student note sheet as well. So you can use that as a resource when answering these. Here are a bunch of examples in terms of writing their formulas, which would be the opposite. So we give you the terms, you write the formulas. Remember that if the first element only has 1, we don't put the mono there. So nitrogen monoxide is NO, nitrogen dioxide, NO2. Dinitrogen trioxide, N2O3, and you can see all the way down. So that is how we go about writing the formulas for covalent bonds. Hopefully you are able to answer everything on your student note sheet, and this gives you enough momentum to start tackling these problems. But feel free to look forward to some screencasts on covalent bonding, writing the formulas, naming them, as well as drawing the Lewis dot structures to assist you with this process. All right. This is all I got for this screencast. Thank you for watching. If you have questions, talk to your science teacher. See you later.